All right, so I've added a new feature to RotoWorkshop that I thought I would quickly try to demonstrate for you. So the new feature is an optimizer, so it tries to compute subsets of rows that optimize some criterion subject to certain constraints. And so what I'm going to do is use this new feature with projections that I have for the Premier League. So these are game week 32. It's next week coming up in the Premier League, and this is a model that I put together, combination of a model that I built last year and then some changes I just made recently to try to improve it. And here's what I have for game week 32: each player, their team, their position, their price, and then the projected points. Prices they actually should be this divided by 10. So Raheem Sterling's price is actually 11.6, but I've turned them all into integers by multiplying by 10. All right, so the new feature here is this Optimize tab. So here's how it works. You can choose which column you want to optimize. So it's going to maximize the sum of some columns. So I want to maximize points, and then add constraints to that. So if I just come in and I say, hey, maximize points, it's just going to say, take every single row that has a non-zero number of points and put them all together. That's the maximum points you can achieve. The problem only gets interesting once you add some constraints that are trying to bound certain things from above. So in this case, we have a restriction in the Fantasy Premier League game. We have a restriction on budget. So we have a total amount that we can spend on players. So for this one, I'm going to do is I'm going to assume that I'm only going to look at the starting players, and I'm going to leave myself, 15 or so million pounds to pay backup players. And so I'm going to set in a price of, say, 840, so 84 million pounds. And subject to that price constraint, maximize the points. So I'll click this, and you quickly get the answer. So this is the subset of rows that maximizes the points, subject to the price being less than 84 million. So as you can see, it's a lot of very low-priced players and a very large number of them. In fact, more than I can actually play. In the game, you can only play 11 players. And if I click on this, I can sort them by position, and you'll see the optimal lineup here has only one forward. It has seven. It has 7 goalkeepers. You can only play 1 goalkeeper. So this obviously isn't going to work. This isn't a reasonable solution because I haven't incorporated all the appropriate constraints. So let me go back and try to optimize this again. Maximize points. I want the price to be below 84 million pounds, but I'm also going to set constraints on the position. So I'll say the count of rows where the position is goalkeeper should be at most 1. I only want 1 goalkeeper. And the count of position that is defender is 3. The count of position that is midfielder will be 4. And the count of the position that is forward will be 3. So this is going to be a 3-4-3 formation for the team. In the game you can actually choose some other ones, and so if you wanted to try those all, you could play around with the different combinations and see what works best. Okay, so now I'm going to run this, and you can see now that I've added these more constraints, it's taking a little bit longer, but still pretty quick. It should be done in just a second here. And here we go. So this is the optimal team. We sort it by position. So this now has 3 defenders, 3 forwards, 4 midfielders, and a goalkeeper. So that all looks fine, and this looks like a good lineup. However, you'll notice there is another problem, which is if you look at the team column, I have 6 players from Manchester City. Manchester City play 2 games this week against 2 very weak opponents, so it makes sense that their projections are all very high, but you can't actually play more than 3 players from the same team in the game. So I need to add yet more constraints. In many weeks that would just give me an optimal lineup, but this week it doesn't work because of the fact that there's so Man City has such a good fixture this week. So here's what I'll do. I'm going to set the sum of the price as before to be 840, and then I'm going to add all the position constraints. I want 1 goalkeeper. I want 3 defenders. want 4 midfielders and 3 forwards. Okay, but that's not all. I'm going to add some more constraints here. And actually, before I do that, let me just mention this part down next to the Optimize button. It has some information that gives you a clue about how long this is going to take. So it tells you how much memory it's going to need for the algorithm that it's going to run. It's going to end up allocating arrays that use 4.3 megabytes of memory. That doesn't seem like a big deal. And it's going to explore 29 million different combinations. So we're going to add some more constraints in terms of the team. So I want them at most 3 from Man City. You can see we're now up to 118 million combinations and 17 megabytes of memory. And actually, I'm going to add one more because I've done this before, and I actually know that if I do that, it's going to end up with 4 Chelsea players. So I'm going to add a constraint that there are only 3 Chelsea players. And now the number of combinations it has to explore is up to 473 million, and it needs 70 megabytes of memory. So 473 million, that sounds like a lot, but of course, computers are very fast these days. So, this won't necessarily take an absurd amount of time, but we'll click the button and we'll see how long it takes. So as you add more constraints, this amount of memory and the amount of combinations it's going to have to explore is going to go up. Okay, so we'll click this. And you can see it's moving quite a bit more slowly now. So it's getting about 1% every 1 to 2 seconds. So this whole thing, should finish in, 2 minutes, say. That said, I think you'll see, let me just explain a little bit about how the algorithm works. It actually has 2 phases to it. And the first phase, I have it's showing you up to 50% is just this first phase. And then the second phase, the first phase is actually just figuring out what the optimal points that can be achieved are. And then in the second phase, it's going through and actually figuring out what the team was that achieved that. And the second phase is actually quite a bit faster than the first phase. So that said, I don't know exactly how fast it's going to be. So these percentages are estimates. But everything from 0 to 50, that is that's a correct description of how long it's going to take to get 50%. That's going to go proportionally the way that it is. But I just don't know the first 50% versus the second 50%. I'm never sure quite how to weight those. So I put them as equal weight so that it thinks it's going to take half the time in the first 50% and half the time in the second, when in reality it's probably going to be faster in the first half than in the second half. Also, the second half, just all the different things that it's doing, there's a lot more guesswork in the second half. So as you'll see, the second half goes faster, and it's going to do a bit more jumping because I don't really know how long those parts of it are going to take. So this whole estimate altogether that it shows here of 43%, that's a very conservative assumption. It's in almost all circumstances it's going to be faster than that. So here we go. We're almost at 50%, and in just a second you're going to see this. We should see it speed up quite a bit. So we're at 50, and then it's going faster. And then even faster, etc. So almost done here, and as you can see, this again, the numbers are all, it's actually faster than it looks like it's going to be. Okay, so there we go. This is the optimal lineup. It does have the 3 forwards, 4 midfielders, 3 defenders, and a goalkeeper, and it has restricted it to just 3 Man City players now instead of the 7 we started with and 3 Chelsea players. And so this is the optimal lineup for Game Week 32. So anyway, hopefully this optimized feature will be useful to you. And if you run into any problems, just hit me up on Twitter. It's at KCZat. All right, thank you very much.